In the future, you're going to have to identify several minerals on your lab practical. The lab practical is considered part D of the earth science regions, and it's worth about 20% of your total region score. So how do we go about identifying minerals? What are the steps? What are the main steps? Well, let me show you. When you go about identifying minerals, there's a couple of things that you're going to have. One is going to be a glass slide or glass plate, and the other is going to be a porcelain plate. Now, the glass slide you're going to use to test for the hardness, and the hardness is based on Mohs scale, which is 1 to 10, 1 being the softest, 10 being the hardest. Now, glass has a hardness of about 5.5. If the mineral can scratch the glass, then has a hardness of greater than 5.5. If it doesn't, it's less than 5.5. The porcelain plate is used to find the streak. Basically, it's the powder left by the mineral being scratched on a hard surface. Now, some minerals are going to have the same streak powder as its appearance, and others are going to have a different colored powder. So let's try to identify one. Now, when you identify a mineral, you're either going to have some sort of a flow chart, or you're going to have your earth science reference table. And just a quick review. The earth science reference table for minerals it's broken up into several categories. Okay, it's going to tell you the luster, the hardness, cleavage, fracture, common colors, distinguishing characteristics, its uses, the composition, and finally the mineral name. So essentially, this is going to be a process of elimination. Okay, so let's use this mineral right here. First thing you may want to look at is its luster. Now, luster refers to the shine of the mineral. It's either going to be metallic or non-metallic. When you look at this mineral here, this mineral has a transparent appearance. It doesn't shine like metal. Okay, it doesn't have a characteristics of looking or shining like metal. So this would be considered non-metallic. So when you look at your reference table, you can eliminate all the choices, all the minerals that are considered metallic or have metallic luster. You can eliminate all these guys. So now we have to consider the ones that are non-metallic. Then you look at the cleavage. And obviously this mineral, based on definition, has cleavage. Okay, it has nice flat smooth surfaces. Also, the sides are parallel to each other. Okay, so now you have to look at the ones that have cleavage. So essentially you're going to eliminate all the ones that have fracture. Okay, so now you have to narrow it down further. At this point, you can perform a scratch test. Okay, you're going to test for the hardness. Now again, if the mineral scratches the glass, it has a hardness of greater than 5.5. If it doesn't, it's less than 5.5. So I'm going to try to scratch the glass with this mineral. As you can see, if you can't see, it doesn't scratch the glass. So it's less than 5.5. So now we have to narrow it down. Is one of these minerals that are less, that has a hardness of less than 5.5. Now you perform the streak. Okay, let's try to perform the streak, see what color that we get. Okay, and if you can see, you get a white streak. Okay, you get a white streak. You go back to the reference tables, and you see under common colors or sometime under the distinguishing characteristics, and see which one gives a white streak. Okay, now you may have to look at the physical appearance or shape. Okay, the shape is not cubic, but more of a rhombohedral. Okay, or a rhombohedral. So you look at your choices. Okay, and well, let's see. You have one that has a hardness of 3. Okay, It has cleavage. Its color is the variable. Okay. It has rhombohedral cleavage. Okay, and if you look across, this mineral is calcite. Let's try another example. Let's try this mineral right here. Okay. Now this mineral, if you look at it overall, you look for the luster, and it doesn't really shine like metal, so it would be considered non-metallic luster. Okay, so it's non-metallic. So you would eliminate all the ones that are metallic in luster. Now you look at the cleavage, and by definition, this doesn't exhibit cleavage. It doesn't have flat, smooth surfaces. Okay, so it's fracture. It has fracture. So when you go to your reference table, you're going to eliminate all the ones that have cleavage. Okay, so now you're down to 4 choices. 1, 2, 3, 4. Okay, now let's look at the hardness. Okay, you're going to take your mineral and you're going to scratch it against the glass. And let's see if we can show this. Okay, so it's a bit hard to see. It's a bit hard to see, but it scratches the glass. Okay, it scratches the glass. So it has a hardness greater than 5.5. Now when you look at your reference table, you're pretty much down to 3 choices. Okay, and let's just look for the streak. Okay, okay, and the streak color is kind of hard to see, but it's kind of greenish. Okay, kind of brownish or greenish. Okay, and again, now when you look at your reference table, you have a color, or you have choices where it says green to gray or brown. Okay, now you pretty much look at the other characteristics. So you see it's non-metallic, has a hardness of 6.5, it's fractured. Okay, it's green, the streak is green to gray or brown, commonly light green and granular. Okay, so it's light green and granular. Okay, and when you look across, basically what you have here is olivine. So the mineral that we have here is olivine. These are the steps that you need to take to identify your minerals. So what it really comes down to is careful observation and understanding what steps you need to take and the meaning behind the steps. So you have to know what luster means. How do you test for the hardness? You have to be able to recognize the cleavage or the fracture. And sometimes the color of the mineral stands out. For example, green tends to be, or olivine tends to be green. Or going back to one of our known, this yellow here is sulfur. If you practice this, you shouldn't have any problems identifying minerals in the future.